Hello coders, good afternoon. It is Thursday, the 3rd of June. We are in that month of the year. It's crazy. We're firing through 2021. And it's episode 104. Today we're going to be talking about dry programming practices. So dry meaning don't repeat yourself. And what I'm going to be doing today is explaining what that means, and I'm going to be sort of leaning on some of my experiences as to some of the times in which perhaps I haven't created a very dry application, or where I've used dry principles to make my code cleaner. So that's what we're going to be talking about today. Dry programming practices. Don't repeat yourself. But first, as always, thank you for joining today, and cheers, everybody. Today I'm on Midway. It's a nice beer, that. Love it. Right, so dry programming practices. What is this all about? This is something that I was never taught at university or college. This is something that I picked up as I was progressing in my career. It was one of these topics that I just stumbled upon, which then suddenly made a lot of sense. It's been around for ages. It's been around for donkey's years. I can't actually remember when these principles actually came to light, but they make so much sense, and they make your code a lot cleaner. So DRY is the acronym. Don't repeat yourself. And of course, the opposite of dry is wet, which means wastes everybody's time, everyone's time, or write everything twice. So with that in mind, you can kind of gauge where this is going to go, this talk. It's all about writing duplicate code or having duplicate logic in your code. And the reasons why you don't want to have that is because, well, there's many reasons. One is human error. The other one is technical debt. The other reason is that you've got too many. You've got some big maintenance overhead, right? You've got two things that do the same thing. They might be called slightly different, but they have the same outcomes. Or maybe the internals of a particular method or a function run a similar set of routines that could be done together, and basically, when you don't repeat yourself, when you start removing duplicate code or removing duplicate processes, you make your code leaner and lighter, and you reduce like I said, the maintenance overhead. You make it cleaner and easier to read. Okay. So having a clean code base is a good practice to get into, right? That is nobody likes to read messy code. Nobody appreciates messy code, right? You always want to try and make your code as easy to read as possible, and make it as clean and less code smelly as possible, because it makes it, like I said, easier to read. It makes it to run smoother. It makes it easier to debug issues. And one way to have a cleaner code base is to use this don't repeat yourself programming principle. Now, this principle covers all programming languages, and it doesn't just focus on programming languages. You can actually use this in other software development sort of areas, if you will. So, for instance, a database schema, okay? You won't have duplication in a database schema, will you? You won't have two tables the same name, or just, table _1 and table _2 with exactly the same fields in there. You wouldn't dream of doing that. So you're always, and this is a word I'll use more later on, you'll always have a single source of truth when it comes to a database, right? The user will only be in one user table in your database. You won't have that floating about in other tables in your database, because then which one do you call upon, which one is your single source of truth. And you can use that when you're writing your code. What is your single source of truth when dealing with data within your application? So it is aimed at reducing repetition of information. Okay, so that's essentially what I've just mentioned. It reduces the duplication of information and data and logic and processes and routines. And by removing duplication, it means that your code is far lighter, far leaner, easier to read and maintain, as I've mentioned. The opposite of this, of course, is wet. This is where you have lots of different pockets of code, or if we were to use the database schema analogy, lots of little tables that have very similar data that are called very similar things. And essentially what you're doing is you're wasting people's time by having really fragmented pieces of data like that, where you've got lots of pockets of code that do very similar things, where you're perhaps assigning models in various places or creating models in various places that do the same thing, instead of boiling it down to a single place. And the reason why this wastes people's time is it's very difficult to debug and maintain, and it's very difficult to improve, and it's very difficult to understand, because when you are having to go through all these hoops of duplication, you have to be aware of where, of what you need to adjust. Not just the thing that you might be working on, but perhaps it's used somewhere else. Excuse me. So yeah, this is a topic again that I was never taught at uni or at college, but it's something that is so important that every programmer, regardless of whether you're a JavaScript dev, regardless of whether you're a DBA or whether you're a PHP or a Python programmer or a Go programmer, everybody needs to understand dry programming principles. Okay, so how do you get to dry? Okay, what happens? Maybe you've been given a legacy code base full of duplication. What do you do? How do you approach this? So one way is abstraction. Okay, so abstraction is a process of taking what you're working on in terms of, say for instance, you were building an e-commerce shopping cart that was selling, I don't know, 1 minute it was selling shoes and the next minute it was selling jeans, right? So you would have a variable called shoes, and then next month you would have a variable called jeans. Okay, but actually what you're doing is you're selling products. So you would create, maybe these aren't variables, maybe these are classes. So you would have a class for jeans and a class for shoes. Well, both the jeans and the shoes need to have a price. Both jeans and shoes need to have a size, although those sizes are dictated by the type of product that you're using. But they both boil down to a single product. So if you were to look at this in terms of a relational database, for instance, you won't have a table of shoes and you won't have a table of what did I say, jeans. You would have a table of products, and then your table of products would have perhaps a product type and maybe a product configuration table that changes the options and the config of those particular entities. Same with the code, right? So you won't have a variable called jeans, and you won't have a variable called I've forgotten already, shoes, right? You would have a variable called product, and then you would have maybe a product type, and based on that type, whether it's jeans or whether it's shoes, you offer the various different sizes at checkout. But they will all have a price, they'll all have a VAT or a tax calculation, they'll all possibly have a discount code, they'll all have a stock, right? So you're basically combining the common things, and you're abstracting this into sort of going a level above and saying, well, actually, these are products. And so what is a product? Well, a product needs a stock amount. It needs a price. You know, it needs delivery charges. It needs all of those kind of things. And then you have the specific pieces of data for those specific products. But those specific pieces of data are handled in their own sort of in their own right. Okay, so abstraction is the goal, is to make your code reusable. That's essentially it, right? So you've created a product, and you can reuse that in various different types of products. So like we said, jeans and shoes here. So the goal of abstraction is to abstract the code into reusable sections so that you're not duplicating it everywhere. It involves using key concepts like inheritance. So for instance, if you had if you had a product, right, you may have like a base class called product, and that base class may have various different methods on there that every product needs to have. But then you may have a specific product which extends the product base class, which then overrides using inheritance one of the methods that it extends. Include, you know, it might be a price override or something like that. So you then make this sort of base class stroke model sort of relationship in your code. And in the base class, you put all the common logic, and that is the logic that is common to all of the other classes that extend from your abstraction. Yeah, another way of doing this is also writing utility classes. Okay, so this could be if, for instance, you were to, I don't know, use some way of communicating to the database, and you might be using some way of constructing a query, for instance. Well, you might be doing that in perhaps a static way, and so you might be calling upon static classes or static utility methods to construct your query, and then run it through, you know, your query builder or something like that. So this is where you can move static utility things outside of outside of the product domain, perhaps. Yeah. The next one, this one here is this is an interesting one because it's something that I fall foul of. I fall afoul a lot of all of these, to be honest. I'll go through some of these with my experience as well. The other one is the rule of three, right? Now, this is interesting because it's the rule of three, not the rule of two. So this is where you have, if you have an identical code in more than 3 places. Now, what is identical code? It's not a one-to-one. It doesn't always have to be a one-to-one. It could be code that perhaps is in if you see a lot of code in a switch statement or a bunch of if statements, right? If-else statements. And all they're doing is they're outputting some, I don't know, maybe they're outputting a message to the page or a log message, or they're going through a series of checks and throwing an exception depending on whether these if statements are true or whether the switch statements cases are true, something like that. And they're rattling through this if sort of thing. And maybe what you've done or you've seen is in the outputs. The output is actually exactly the same, but it's the type that you're switching on, or the check that you're doing, that is concatenated to the output. So for instance, if you were running through, this is very difficult to explain without actually showing you the code. But let's say, for instance, you were doing a load of validation and you inputted, you added, or in the input, you would have like this thing that you want to validate. Maybe it was a string, and you want to make sure that this string doesn't equal to this or this or this or this. And so you would run it through a bunch of if-else statements, if-else, if-else, else if, else if. And then at the bottom, the last one is it's valid, right? Because it's gone through all the validation checks. And all you're doing is you're adjusting an error message. And the error message is exactly the same, but the only thing you've changed is maybe the concatenation of the thing that you're checking, right? So you're checking a string, and you've got a load of duplication there. So what I would do in that case is I would put those pieces of checking code in an array and loop over that array, or do an if-in array or something like that, where you're only doing that once, and you're storing the outcome in an array, and then you're outputting the relevant outcome, and concatenating wherever you need to be. That means you're not creating a whole bunch of if blocks or switch statements. So you're basically reducing the code, and you're making it into a single check rather than several checks. The thing is, when you've got several checks, that means you've got to do several tests, which means that there's several areas of human error. So when you're running lots and lots of if statements or switch statements, or God forbid, switch statements in if statements in switch statements, I've seen that today, there is a danger of code duplication, and it's a code smell, essentially. It's a code smell. Okay, so the rule of three, I kind of went off on a bit of a tangent then. The rule of three is if you see identical code 3 times, although it doesn't have to be identical code, if you can see a process happening 3 times, or a routine being run more than 3 times, then it really should be abstracted into a common method or a class or something that is reusable and more easy to maintain. Now, the reason why I fall foul of this a lot is that sometimes I'll go into a situation with abstraction in mind without even considering the real need for it. So when I start cutting code, occasionally I will already have the abstractions in my head, and I will create the abstractions without any real need for it. And this is a massive contradiction, because abstracting something is quite difficult, because it takes a lot of thought. It's always best to abstract after the fact rather than to create the abstraction when you don't need it. This is a contradiction to the next piece, which is keep it simple, stupid. And when I say a contradiction, this is me falling foul of this, because I've fallen foul of the first rule. Because I've fallen foul of the first rule, which is the rule of 3, because I've abstracted it, because I've only got the one thing to worry about rather than multiple things, so multiple, and I'm overcomplicating it. This is over-engineering it. I accept that I over-engineer a lot. Keep it simple, stupid, or KISS. There are a few ways to keep your code nice and simple. For instance, don't cram too much into one method or function. Plan out your user flow, and make your code design nice and clean, but don't over abstract if you don't need to, right? If you don't need to do the abstraction, if you only have one place where this is actually running, then you don't need to abstract it. So that's a problem that I've got. I always go into this with the abstraction in mind, and my excuse is usually, oh well, in the future I might do this. I might need this level of abstraction, this need for reusable code, but half the time it never actually happens. So doing dry works best when you're working on code that is already written, that you've already produced. Trying to do this without even trying to write dry off the hoof is quite complicated and quite difficult, in my opinion anyway, in my opinion. Martin is saying, I find learning Node.js is the best way to understand internet protocols. Node.js, I'm not a massive fan of Node.js. Personally, I'm not a massive fan of running JavaScript on the server, but then, hey, I'm a typical PHP and Python dev, so I would say that, right? But really, it doesn't matter what language that you're using, or what thing you're doing. All of these principles apply. So the next one is separation of concerns, right? Single responsibility. So if your application, or sorry, if your method or your class or whatever it is that you're writing is doing more than one thing, that means that it's got more than one responsibility, which means that it needs to be refactored and made smaller. I'm a massive fan of very, very small methods. Small methods where when you read the method name, it says exactly what you're going to get in return. All right, so you or what you need. Yeah. So for instance, I like my long method names and my short variable names. So for instance, I may have a getter that says get such and such. That tells me exactly what I'm going to get by such and such, and that is what I'm going to input. So I don't know, if we were to talk about the products again, I would do get price, right? So I know I'm going to get a price by product ID. That means I know I need to supply a product ID, right? So that in my opinion is a very nice, succinct method name. It tells you exactly what you're going to get back, and it tells you what you need to include and input. But if that get price by product ID also does some crazy calculation, which relies on a bunch of code from somewhere else, then and maybe does some sort of VAT calculation or tax calculation, and then maybe does some sort of delivery calculation as well, so shipping costs and all of that stuff. Then it's doing a lot of things. It's not actually you're returning the product price, but you're also returning the product price in the context of tax and shipping cost. So what I would do is break those up into smaller little chunks, smaller little methods. So you got your get product price by product ID, or get price by product ID. You might want to have get tax by product ID, or you might want to have get shipping cost by product ID. Those kind of methods. And then maybe you would want to have another method that does just, get total or something like that. That then calls on those three things. But those three things have their own single responsibility. The first one, the get price by product ID, perhaps is going to get the recommended retail price. The get tax by product ID is perhaps going to get the tax calculation, get the return of the tax calculation, and so on and so forth. And then maybe you would have calculate total cost by product ID, and you feed that in, and then it runs through those other methods, and there you go. Okay, so separation of concern. That is essentially what we're saying here. You're separating your concerns out into smaller little functions, and those little functions are easier for you to read and understand. They say exactly what they need and what they're going to return. So keep your code organized, separate your code into distinct sections so that you can easily go back and find sections to reuse. Have loosely coupled layers, separate UI from the data layer and the app layer from the integration layer. This will make refactoring simpler, obfuscate as much as possible, and make it easier for partners and other developers to make changes to only the permanent type parts. I'm reading from metover.com. I'll put the link in the show notes after the show. This is an interesting blog article that they've created about this, and I would add around the separation of concerns for creating contracts between perhaps classes to say that this class has these concerns and this class has this concern, that kind of thing. I don't know about the obfuscate as much as possible, maybe. But you basically want to create a nice, small, light classes with nice, small, light methods in. And those classes and those methods should only be concerned with the things that they're actually concerned with. Everything else you should inject or you should have some sort of interface to have some sort of contractual agreement from one class to the other class, perhaps using a bit of composition, which means that you're really making your classes unique. And the whole point of a unique class is the fact that you're not repeating yourself again and again and again and again. Your tax calculations, your product price calculations are only done in one place. And that one place is the next point, which is the single source of truth. So if you've got a shopping cart and you've got many pages that take the user to checkout, maybe they need to register, maybe they need to put in a discount code, maybe they need to do XYZ and all of that jazz, and then they get finally to the last page. And all through that journey, you're calculating prices and you're calculating stuff. You only want to have that calculation done once. In terms of your code, you only want to have that calculation done once. Certainly don't do this in the view. You want to be doing this in some sort of model layer, in maybe a service, and you want to call upon that one service in each of those particular pages. But those pages shouldn't care about the calculation. It's the calculation in the service that should care about that calculation and should be giving you, and you should be running that routine again and again for each one of those pages, leading you up to checkout. You certainly don't want to be creating any other routines that do calculations in various different places. Imagine, if you will, there was a bug in one of these pages, and if these pages had different ways of calculating these things, and it was done on sort of on a controller basis. So maybe you had 3 pages, so that would be 3 controller actions, 3 views and so forth. And maybe you had a calculation on the second page that didn't quite match the calculation on the first page. That certainly didn't match the calculation on the last page. If you had a bug, you had to fix the second page. You would also have to alter the first and the third. And it just gets tricky. So have a single source of truth. Now, also, with this single source of truth, we can go back to the database. Okay, so if you're writing a database schema, only have one table for users, only have one table for products, only have one table for, I don't know, categories. Okay, don't have multiple tables that do the same thing. And perhaps do it slightly differently. Same with field names. So if you're calling user in one table, don't call it customer in another table. Don't call it, you see what I mean? You want to keep it nice and easy to understand and navigate. So there are ways of architecting models and data so that every data element is stored exactly once. They use relational schemas instead of duplication. Yeah, as I've just mentioned here. This can also go a little bit further if you've got, say, classes and arrays, okay, and if you're populating, if you're creating an array from a class, so you've got an array of values, and those values are being populated from this class, this entity that you've got here, and then you manipulate the array, but you don't manipulate the class, the object, right? Then you've got you've disjointed your data. You've essentially duplicated your data, your information, and you've altered one, but you haven't altered the other, which means that now your single source of truth has been changed. So rather than changing the variables in the array or the elements in the array, change the object, change the accessor methods or whatever you need to do, and then just use that. Don't convert it to an array and alter that. It would just be very problematic. I've worked on projects where there are many layers of transformation, shall we say, of one data source to another data source to another data source, and it's essentially like Chinese whispers. As soon as you get to the last layer, it's very different from what it was originally, which can prove problematic. Okay, the next one is you aren't going to need it. This is Yagni. This is interesting one. So keep your code clean and readable. Remove commented out code and dead or unused code. It is just clutter at that point. That is very true. So if you see any code that you're not using, and modern IDEs here do this very well by highlighting code that's never used, or you could use auditing tools and linters and stuff to identify code that's never been read or never been written to. You know, if you've got properties, for instance, of a class and you're not actually doing anything with that property. Or another great example is with PHP Storm, at least, you can see all the, it marks all the namespaces that aren't being used in your class. Sorry, not your namespaces, sorry, your imports. Where you've got use and then the import, it will mark those if it's not being used. So it'll highlight that so you can get rid of it. And there's also a nice little shortcut that I use, which is Control Alt Shift, and I think it's O. I think that's my shortcut key. And it has this optimize imports tick box, so it's in the refactor sort of option, and it will remove all of that stuff. All the dead code, all the dead weight. I would not remove comments though. Okay, comments are really important, especially if they're nice and updated. But I would remove commented out code. Okay, so I would remove commented out code because it's useless code. It doesn't work. It's not being executed. It's not running. It's just furniture that you have to navigate around when you're reading the code. It's useless. So remove that stuff. Remove it. As the blog says, it's just clutter that at that point. It shouldn't be scary if you're using source control because you can always revert back. This cuts down package bloat, making your application smaller because you're removing lines, and fundamentally this makes it easier to read. But there is another point to this Yagni stuff. You aren't going to need it. And that is, again, trying to keep your application as simple as possible. It's interesting how many times just even at a product level, perhaps a feature gets requested, but it hasn't been perhaps researched, as in, do we actually need this? Is this actually going to be required? Or it could come down to the code level where it's you think that you're doing a good job by abstracting your code. You think that it's going to be nice and readable, but actually you're not going to reuse that code anywhere, and therefore you've gone and overcomplicated that code, and so you're not going to need that abstraction. Only do this when you need to do this. That's the whole point of this. If you take one thing away from this, this is you should only make your code dry when it needs to be dry, right? Don't do what I do and just dive into a solution with abstraction and without actually considering the consequences or considering that this code is only going to be used here and never be used anywhere else. Because there's no need to do dry. You should only do it when you need to do it. Because technically, if the code's only been written once, then it's dry already, right? So yeah, the next thing I wanted that was I think it's Metover. It's an interesting blog post, dry programming practices here. But there was something I wanted to talk about as well. There was another one, the Valuable Dev has a nice little blog post about the benefits of, or the dry principal cost benefit example. And this has some really good examples of code that isn't dry and how to make that dry. And one of the examples here is of two classes. One is order return and one is shipment. And the shipment has a public property called delivery time. and it's an integer of 4 in days, okay? And it has a method called calculate delivery date, and it returns a date time. And that does a calculation doing the date time PHP, and it deals with the delivery time property and so forth. The actual routine here doesn't matter. It's the fact that there is another class called order return, which also has a return limit, which is a property, and that is that has days as well, and it also has a method called calculate last return day, which returns a date time. Now, these methods are called totally different things, and they have totally different contexts. The shipment has a context of calculating the delivery day, okay, calculating the day in which it's going to be delivered. The order return is in the context of returning that order, okay, so calculating when that order can be returned. So one is to calculate the delivery date, and the other one is to calculate the last day of return. The calculations, if we remove the context, the calculations are exactly the same. All we're doing is we're changing the name of the method, and we're changing the property name, and we've changed the class name. But actually, the routines are exactly the same. So this is a great example of your code doesn't have to be your complete true one-to-one to be deemed as duplicate. This is an example of the calculation, the logic being completely duplicate. The context don't actually matter in this case. So instead of doing this, you would having two classes that run this same routine. You would perhaps have a base class for date calculations, or I guess you would call this product calculations, or something like product dates, or something like that, or delivery dates maybe, make that a little bit more generic. And you would have perhaps two classes, shipment and order return. Obviously they would do other things than just calculate the delivery days, for instance, but they would extend and they would run a generic routine to calculate based on in the order return, the return limit that's passed, or in shipment's case, it would be delivery time, and you would pass that in as a property to a method, or sorry, an argument to a method that does that calculation. But that calculation is only made once, which means that if there is a bug in that place, you only have to fix it once. You don't have to fix it twice. Yeah. But another point that this blog post, the valuable.dev makes, which is really good, is the fact, and I think I've mentioned it before, is the fact that it's not all about code when you're dealing with dry. So they say dry is not something you should only respect in your code. You should you shouldn't repeat your knowledge of business domain in anything related to your project. So the idea of dry is simple in theory. You shouldn't need to update in parallel multiple things when one change occurs. So for instance, if you change one thing and you have to change that thing in multiple places, then that is a red flag, and that is a code smell, and you need to fix it. that is a case for you not writing dry code. If your knowledge is repeated 2 times in your code and you forget to update one occurrence of the same knowledge, expect bugs and tears. In your documentation, it could lead to misconceptions, confusion, and ultimately wrong implementations. So if you've got documentation that talks about the same thing twice, and one is done from perhaps, was written like in 2000 and whatever, and the other piece of documentation was written last week, and the person reading this is reading the old one and doesn't realize, then that's going to be obviously out of date and they're going to get it wrong. So make sure that, again, this goes back to a single source of truth. So if even in documentation terms, so only have one place, you only have one README file, you only have one install file, right, .md to read. So I will also add this to the list in the show notes too, because this is really good, really, really good. yeah, really like this this blog post. Also, you shouldn't apply the dry principle if your business logic doesn't have any duplication yet. So this is another thing that I mentioned earlier, in the sense that you don't always need to do dry. This is called premature refactoring. As a rule of thumb, trying to apply dry to something which is used only once can lead to premature generalization, which is something that I suffer from. And this is when I go in headfirst and try and abstract something that doesn't need to be abstract, because that's just the way I'm wired. I go, well, this is actually, if we can generalize this a little bit, we can do it this way. And this might give it more future flexibility. But in fact, what I've done is I've enforced some barriers and some rules when I haven't needed to. So it's a bit of a balancing act here. When do I need to use it versus when I don't need to do it? And really what I should be more concentrating on is actually writing the code and then doing the dry after the code is written. This should be something that is post-code cutting. If you begin to generalize something because it could have been useful later, you will spend time to create an abstract classes and whatnot, which might be only used in one place forever. Yes, I've done that before. I have certainly done that before. Business needs to change very quickly and drastically. Today, everybody will tell you that you need some generalization for the future. Tomorrow, everybody will forget about it. That is some really, that's some real strong truth there. And also number 2, again, you will possibly introduce complexity and coupling in your code for no benefit. So by trying to make your code cleaner, you're actually making your code more complicated. Code reuse and code duplication are two different things. Dry states that you shouldn't duplicate knowledge, right? Not that you should code to be able to reuse everything. Okay, this is what I've learned over the years. Code for the specific, don't try to generalize. That is some really good words of advice. Even if your managers would love to have 90% of your application reusable for every single use case, in practice, this is almost never possible. That is some really good pieces of advice here. I love this. Yeah, so this is what I've learned over I just said that. Two functionalities, even if they look very similar at first glance, can be very different in the future. If you have any doubt, it's better to copy your code and let it take different paths. It's way simpler on the long run than having a forest of if statements, which makes your application a machine for confusion and headaches. So duplication is far cheaper than the wrong abstraction. That is a really key point there. Duplication is far cheaper than the wrong abstraction. So yeah, that is today's talk. And basically, this has been a talk where I have basically had a little rant to myself, and I've done it live. Anyway, I'm going to release episode 103, I think it is, tomorrow, in fact, and that's going to go on the podcast. So if you haven't done so already, please do check that out. I know that a lot of you have done so already, which is great. So if you just search for How to Code Well on Spotify or on iTunes or wherever you get your podcasts from, then you can listen to the podcast and listen to all the previous episodes. We had some really fantastic guests on in the previous few seasons. So, and that's something that I would love to do again, is have some guests on and maybe do it live. So look out for that. If that might happen in the coming future, that would be fantastic. But anyway, thank you ever so much for watching. Happy coding, everybody. And I'll see you again live on Twitch actually no, I'm not going to be able to do it this Sunday, so I'll see you again next Tuesday at probably 6:30 on the afternoon BST on YouTube, and we'll do some perhaps PHP 8 work.